Apparently, the systems integration market is worth $500 billion a year. $500 billion just spent connecting different systems together meaningfully. And I don't know whether I should be impressed by that figure or depressed by it. Because on the one hand, it's great that there's so much value in connecting different computer systems together that money is worth spending. On the other, it's depressing that it's so hard that that's what it costs. And I can imagine plenty of senior managers out there with their heads in their hands, wondering why it's this difficult, but having to write the checks anyway. But I think we know why it's so difficult. As programmers, you figure that out the first time you try and connect two systems together. You end up saying, sorry, but it's taking longer than we thought because we've always used JSON, but they've standardized on protobuf. Or they use REST and we've been busily moving over to RabbitMQ and the things don't line up. It's the way systems disagree that bite you. And nearly always, every different system's design decisions made sense in isolation. It's just when you bring the things together that you've got this translation problem. And then you get deeper problems. What about the decisions that aren't just technical? Like, all our user IDs are numbers, and we went to this other system and they don't have a user ID. They do have a customer ID, but it's a string, and it seems to be our user ID prefixed with the letter C, but we're not 100% sure yet. And how do you reconcile all those kinds of data problems? You can spend a lot of time and money trying to stitch things together and still go mad. And you'll have to judge the madness of this week's guest because he thinks he's got a solution. I'm joined this week by Marty Pitt, who clearly went to one data integration meeting too many and decided to create TaxiQL, which is a query language that doesn't care about serialization formats or which storage system you're using, but it does care very deeply about what your data means, and then it works its way outwards from there. It's an idea that's definitely related to domain-driven design and this concept of ubiquitous language, but it's a software solution, it's open source, and most importantly, it doesn't need everyone to agree on ubiquitous language up front before it starts being useful. So, what is TaxiQL and how does it work? Very conveniently, we only need to query one data source to get the answer to that, so let's get going. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Marty Pitt. Marty Pitt, how you doing?
Very well, thank you. How are you, Chris?
I'm very well. I'm glad to see you here. I last saw you on the other side of the planet.
That's
when we were
right,
at a
yes.
conference for the OWL conference tour, right?
That's right. 3 conferences, three different cities. Yeah, it was great.
That was very good. Hopefully we get to do that again this year.
Yeah, if you're listening now, we'd love another go.
Yeah, if we manage to get through the next hour and sound good, maybe this is our application to come back.
Absolutely.
Right, well, best thing for our supper. So, I want to talk about what you've built, but I want to start with the familiar and very thorny place where you found the problems worth tackling, because you've worked in like banking, right?
Yeah. So, my background is software developer for a long time, and I was kind of the tech lead or CTO kind of director at a tech consultancy, and we did a lot of work with kind of large banks. And a lot of those projects turned out to be fundamentally data integration projects, right? So we'd be pulling data from databases or from APIs or from like CSV files. And so often we would end up with these like massive mapping spreadsheets that would say, this field in this file needs to map to that field and that API, and then needs to map to some other thing and some other thing. And these BAs would spend literally months before a project started curating these spreadsheets and kind of tracking down all the different data sources that you needed for a project. And then they would hand them over to the dev team to say, right, for this project, we need to stitch together all of this data. And so that would be the thing that they would hand over. And, kind of prior to that, I had been working I've been doing a huge amount of stuff in open source, and I've been doing a bunch of stuff with, at the time it was called Swagger. These days we know it as Open API.
Yeah.
And I'd written a bunch of kind of like Spring Java-y kind of tooling for Swagger. And so I was kind of in the headspace of automated machine-readable API specs. And that was at the time when, if for those of us that are old enough to remember, when it was just super cool that you could, with a little bit of tooling, you could get this UI that looked great over an API. And like it gave you this great way of browsing your API and interacting with it. So like Swagger was really cool at the time. Still is now.
It would make your front-end people happy.
Exactly.
Finally had a way to discover this stuff, right?
And it just, and we were doing these projects, and we had these spreadsheets, these mapping spreadsheets, and then inevitably someone would go and try and track down, the Swagger spec or the Open API spec, and then we'd look at that, and we'd look at the mapping spreadsheet, and we'd generate our clients, and we'd kind of wire together these integrations and like map some fields together, and then write some code to go and fetch data from another API and then map that together. And it was just kind of this string of field mappings and integrations, and it just felt nuts, right? And the question I was asking myself was, we have these machine-readable specs that describe where all of this data is. And yet the very first thing that we're kind of doing is handing those machine-readable specs off to a person to look at and start coding up integration. I'm like, this is kind of broken, right? Like, why can't these machines just read the specs and work out how to stitch everything together? And the idea kind of formed of this amazing nirvana where if everything has an Open API spec or an Avro spec or a protobuf spec, it has some kind of machine-readable spec, not particularly fussy about what kind. But the idea formed, if we had all of these machine-readable specs and software kind of was able to read them, would software be able to build all of the glue for us? Because it's not just the time spent kind of finding the APIs and doing all of those mapping exercises, but it's the coding of it's kind of boilerplate code, right, to stitch the stuff together. Yeah. And then there's a huge amount of maintenance that goes on after you ship it when an API changes, or someone needs to move a database. They're like, you can't talk to our database anymore. You've got to go through a REST API, so everyone has to refactor to the REST API. And then they go, well, you can't go to our REST API anymore because now we have Snowflake. So it's, everyone goes back to the database. And like, as organizations are changing, all this glue code is, it has to be repaired and maintained. And it's really burdensome.
Can I ask you a deliberately challenging question on that? If you're one of those companies that supplies banks that keep getting into that same situation, is there not a bread and butter kind of boring integration and constantly stitching things together is how we make money thing?
Well, I think it breaks down into two parts, right? I think for kind of third-party APIs, I think that's a really nicely solved problem. Like, I think tools like Fivetran or Airbyte, or these tools that they come out, and like Airbyte's open sourced 50 kajillion different connectors for connecting Slack to Google Sheets to HubSpot. So for kind of off-the-shelf third-party API connectors, it feels like there are platforms out there doing a really good job in that space.
Okay.
I think the reality in kind of mid to large size organizations where software developers sit and work, that are building Kafka streams and that are building microservices and that are building bespoke internal software. Like, microservices is a great example. If you work in an organization that has 100, 200, 1,000 microservices, you can't go to Fivetran or Airbyte and get a connector for the microservice that Tim, who sits next to you, wrote, right? Like, there's no off-the-shelf connector for that. And so then you end up falling down to, they have like this generic REST connector where actually it's not giving you a huge amount of value, right? It's not you still end up having to do all of the tracking down of the fields and the mapping of the data, and like you still have to do all of that, and that gets encoded in your integration. It's not like it's kind of lost institutional knowledge. All of that knowledge of how does this API connect to that API is held in the head of the developer who solved for that problem at that point in time, and then they move on, and all that's left behind is the code that they wrote. So I think that's a much more interesting, much more difficult problem, and the problem of how do we connect bespoke software where you can't get.
Which there's, if you want to find a large number of bespoke data services, a bank or an insurance broker is where you go to, right?
Yeah, but well, I mean, not just them. I mean, microservices were all the rage. Lambdas these days, if you've got serverless functions, they are the same thing. Kafka events that are dropping messages onto a Kafka topic, that's essentially a bespoke API. Our organizations, I think, are more and more a blend of third parties like cloud-based SaaSes that we're pulling in, and then the internal logic that makes our stuff kind of internally unique and tick. And often that is microservices or Lambdas or, Nest.js apps or something like that.
Yeah.
And they need to talk to each other.
So did you have like a moment where you had some big insight that made you say, I'm going to jump ship and build this as my own company?
I had this idea of it shouldn't be this hard. Right, like
fair enough.
Surely there's a simpler way of doing this, and so I started kind of noodling on it as an idea, and the the idea of how can we add information into these API specs or into these machine readable specs so that we can work out how they relate. And I think what we did do is we spent a lot of time looking at kind of prior art in the space that I think hasn't worked out as well as people had thought it was. So, that client in particular had gone, and we'd seen this a lot, it had gone down like this big road of enterprise domain models where you have like one representation, thou shalt only represent a customer in this way. So there is one way of representing customers, and all systems that exchange data about a customer must adhere to the same contract. Yeah. And we kind of, we looked at that and we thought, well, that's a really bad idea because, if you ever want to change that, now every single system has to change. And if you ever have a piece of information that doesn't neatly conform to the golden view of what a customer is, you end up with like, extra data 23, and you start shoving business critical information into extra data 23.
Because you have to ship.
You've got to stick it somewhere, right? And so then you ping the other team on Slack and go, look, that the customer's account balance, we've stuck that in extra data number 23, and they're like, cool, great. And then they go and pull it. They go and pull it.
And it sounds like you're joking, but this kind of stuff actually does happen, right?
Yeah, no, we were. I mean, genuinely, the customer was a bank, and they were trading an entire financial product based on extra data fields. It was because the product couldn't be represented neatly inside of the existing pre-thought of concepts. Yeah. So we knew we didn't want to do that. And, we knew from kind of talking to different teams that that engineering teams will argue deeply about and will care passionately about how their domain models an idea. And I think that's right. I think that two different teams should have different representations of different things. Right. Oh, sorry, of the same thing. So two different teams that are modeling the idea of a customer or of a account or of a, they will name those and have different attributes that make sense to them and kind of their domain. And so we knew that we didn't want to align around field names because that, trying to get teams to align around field names it's just a battle.
Yeah.
But actually,
it's a recipe for a holy war, right?
Yeah, exactly.
Yeah.
But no, the aha moment was the spreadsheet, this awful spreadsheet that had
sentences that have never been uttered in history. The aha moment was the spreadsheet.
Well, I was looking at it and I was like, this spreadsheet has got like 1,000 rows, and they've numbered everything. Like they've created this catalog and they've said, okay, well this is this is business concept 1 and business concept 2, and like they gave everything like this numeric concept, and then they went into their spec documents and they did a great job of this. It was a little bit hieroglyphics because they used like this weird numbering scheme, but they did a great job of saying, yeah, these business rules can be expressed as kind of business concept 1 and business concept 2, and then you'd go and look it up on the spreadsheet and you'd go, okay, business concept 1 comes from that system, so I've got to go and get the API doc from that system. So they had this huge spreadsheet that for this really large project described all the data and all the systems that it came from and how it related and how to do like entity resolution, because like one team uses one set of industry standards and another team uses a different set of industry standards. And so you've got to resolve those. And all of this information was in the spreadsheet, right? It's like, man, why don't we take those business concept ideas, those catalogs, and just embed them directly in the API specs, right? We're not like, don't say this field is the same as that field from that other system, right? Because that couples the two systems together. But instead just say this field is this business concept, right? This field is an ISIN, or this field is a first name or a customer ID or a date of birth. And if you do it at the field level, not at the object level, but if you do it kind of at the scalar field level,
yeah,
then you don't have a holy war around what fields belong in the concept of customer, because each team is deciding what a customer is for themselves. But what you do have agreement on is this thing that I've called first name and this thing that you've called given name. Like it's the same business idea, right? They're interchangeable. The semantics of these fields are interchangeable. It doesn't really matter what the field names are, but the semantics are interchangeable. And that was really what the spreadsheet was trying to show, right? Was these are all the business concepts that relate to this huge big project, and this is how each of these different systems represent these business concepts, and this is how those business concepts are used in like our rules and our requirements. And so yeah, the idea was, well, why don't we just take those and embed them in the specs? And yeah,
the big question there is surely how, because the centralized spreadsheet, that's equivalent to your one department decides the domain model for the entire organization. Are you pushing that down to individual teams? And surely then you still have an agreement problem?
Well, the agreement problem is a little bit different. So you agree on semantics. You agree on the definition of a business concept, right? And that's a little bit more difficult to be contentious about, because when you think about the way that we build integration, when an engineer sits down and they map two different fields, like, you know, two different fields from two different systems together, and they say, right, this thing connects to that thing. And maybe they'll do it by like firing up Postman and looking at the results that are coming in and kind of eyeballing the data and go, this field and that field are the same thing, so I'm going to write some code to glue them together.
Mm.
That's not contentious because it's just a fact, right? This thing and that thing are the same thing. Or they're not. And that's also a thing that you should capture, right? If this thing and that thing look the same, but maybe you're missing some context around it, right? Like they both look like dates, but one is, maybe one is the date that you moved into a house and another is the date that you started paying the electricity for that house, right? These are things that they're either the same idea or they're not. And it's not as contentious as, well, how do I model the concept of an account holder for the house? Like that is a contentious topic. But the semantics of the data is not contentious. And a lot of organizations are already thinking about this by having things like data catalogs, or if you go back even further, having things like ubiquitous language, right? Ubiquitous language is not a new idea. And it's just a way of saying, hey, these are the ideas of our business, and it's important that we understand what these are, right? Like the account start date, like the date that you moved in versus the date that you started paying for the bills. It's important that we understand the difference between those things, and it's not contentious; it's factual.
Okay, tell me how you actually do that. Because let's say we've got 5 departments, and they all have different names for my social security number.
Yep.
Pick something universal. They all have different names, but you recognize that that's one semantic concept you could potentially join on.
Mm-hmm.
Who is... How do you get that? Do you have to have those 5 departments agree and say this is semantic concept number 12?
I think ultimately you need to get to agreement, right? But I also happen to think that if you try and get 5 departments to come together and you say, right, write down all of the ideas of your business, that's kind of a recipe for failure. So I think,
Yeah.
like any good project, the way that you get there is incrementally and iteratively. And generally what happens is you are introducing a new library of ideas. And, in our software, we call that a taxonomy, right? Which is, it's independent of any given system. It is just a collection of nouns that describe ideas from your business. First name, in your case, social security number. And you just assign an ID to it. And a name to it. And it doesn't have to be the same, like, we don't have to have the same field names, because what we're going to do is add that as additional metadata on top of your domain model. So what you call as SSN and what I call as social security number, and someone else calls it, SSID or whatever. What we're going to do is we're going to say, fundamentally, that is this piece of information. So I'm just going to go to the taxonomy, look up what is the name in our kind of ubiquitous language for this. And I'm just going to say, this field name is a social security number. And it's that idea from our kind of central business catalog. And you just do that incrementally and iteratively.
But who's taking responsibility for that? Is it all of those 5 departments, or is it the 6th department that wants to use the information?
I think it's a question of maturity, right? Like the first bank that we did this with, they had a team that was directly responsible for kind of curating a data catalog of ideas. And so that was the team that had pulled together the spreadsheet. And that was a team who said, here's 100 different ideas that describe our business. That's kind of like an ultimate level of maturity. But I think you can get a long way by starting much simpler than that. And you have a shared code repo. Like for us, all of this stuff lives in Git. You have a shared code repo and like a nice browsable catalog that sits over that. So when you want to start like sharing your data semantically, you have a catalog that you can go to and you can look it up and say, right, well, what is the name that we're using for social security numbers? Like, what is the concept in the taxonomy for that? And browsing that and finding the tag and then adding that into your stack.
So what does that look like then? If I start writing this, just take me through the files that will actually get written to describe this.
So this is where we kind of get into Taxi. Taxi is a type system for kind of system agnostically describing semantic types. It's a very kind of simple type system that lets you say, hey, we have this idea of first name of last name, and first name is a string and last name is a string, and social security number is a string, I think. Isn't it?
It's formatted digits, isn't it?
Yeah, so maybe it's a bit stringy. Yeah. And so you just create a Taxi project that just kind of declares those ideas, and you add some nice markdown documentation to say this is what this idea is. And that's a thing that, because these are not systems, because they're the semantic terms of our business, it's generally a thing that you work on collaboratively, but it doesn't change a lot, right? Like, we don't often change. There's a bit of activity when it's first getting going, but then it settles down pretty quickly, right? Because the semantics of our business don't really evolve a huge amount. So you have a Taxi project that has those ideas sitting inside of it. And then each of the individual teams that are wanting to add the semantic metadata into their systems, well, they do it with whatever system they're already using. So teams that are using Avro, they add metadata into their Avro specs. Teams that are using Protobuf, they can add metadata into their Protobuf. Teams that are using OpenAPI. And all it is just a little bit of additional metadata that says this field is not just any old string, but it is a social security number as defined in this taxonomy. And it's just semantic metadata. So it's everything that our specs were before, plus a little bit more that talks about what is this information, and how does it relate to other ideas across the organization.
Okay. I've got a couple of questions on that. The first one is, let's say I'm doing that and I persuade 4 out of my 5 departments to publish this data fairly quickly. Yep. Am I locked out of querying the 5th, or can I just put a stub in on my side until the 5th one is ready?
Yeah, I mean, you can you can do that on their behalf, right? If the fifth team is just not ready. And a good example is external data, right? Like if you're pulling in external data, you're not going to go up to Stripe and say, hey, would you mind embedding these tags that describe, esoteric banks concept for social security number? Like that's not going to happen. So you can just you can polyfill it yourself.
Okay.
But there's a bunch of reasons why producers don't mind doing it. Like it's not actually particularly burdensome to do it. And then for teams that are connecting to their APIs semantically, it actually decouples producers and consumers, which for the producers of the system frees them up. Because the whole idea around this, the whole kind of why, was not to create some massive data catalog that tells you what every field in every different system means. That's a benefit that you get from it, but that's not the real reason. The real reason is to decouple producers and consumers so that consumers can ask for data semantically without really having to be aware of which producers are serving it. And then the middleware becomes responsible for it. And so the benefit for the producers is they can then start evolving their APIs without breaking their consumers. Right. So today, when we build kind of integration traditionally, you give me your open API spec, I chuck it into my IDE, and I generate a client, and we are tightly coupled. Right. Your spec and my client must evolve in lockstep. Or you can kind of go through the gymnastics of how do you version a REST API. Like these things have to evolve together very, very, very carefully. But if you can decouple them, and the consumers are consuming data semantically and the producers are producing data semantically, then you become coupled to the semantic concepts, which actually don't change very much, right? Like the idea of a social security number doesn't change in a business nearly as frequently as the name of the field that models it, or where you stick that field in your JSON structure. Like that changes all the time. Yeah. But a social security number, semantically as an idea, just doesn't change very much. So for you as a consumer, you say, hey, I want to know about Chris, and I want to know his name, age, date of birth, and his social security number. And where that comes from and how I get that data and which fields the producer wrote that in are not super interesting to me as a consumer. I just want my data vended.
Yeah. So I'm thinking, so the unit of decoupling here, it's like there are a lot of people in the Kafka world who say decouple these producers and consumers by putting the data in one format in one place. Not necessarily, let's stick everything in Avro in a long log. What you're saying is let's decouple it by focusing on individual meanings of fields.
Well, yeah, I would argue with all the love in the world that Kafka example, they're not decoupled, right? They're very tightly coupled. They're coupled to the Avro spec. So you might not be coupled to the actual producing system, but you're coupled to the contract that the producing system evolved. You can't rename a field in Avro and then without breaking the consumers, right? If I yesterday wrote my data to a field called SSN and today I write it to a field called social security number, my consumers need to be aware of that change and they need to evolve with it. So they are tightly coupled.
Yeah, I think there might be support in Avro for straight renames, but it quickly gets possibly. But there are cases where it's more difficult.
Or if you want to decompose data, if you want to reshape it, put it into different locations, if you want to nest it in different ways, right? Like the consumers need to be aware of those changes because they need to know where they're reading this data from.
Yeah. And certainly it's like Avro, if it has support for renaming fields, they are definitely thinking at the field level, the meaning of individual fields. Right?
Yeah.
In this semantic sense, we've renamed it, but it still means the same thing, and that's what you're getting at.
Yeah, exactly. Like the meaning of the field, the meaning of the data that's sitting in the field hasn't changed.
Okay. So I write or get other departments to write all these files that ascribe meaning to particular fields.
They ascribe. So teams publish the idea of a taxonomy, which is these ideas exist in our business, and then then publishing teams add that metadata into their data contracts, right? They say this field is a social security number, this field is a first name, is a last name. So they become consumers of the taxonomy. Yeah.
Yeah, okay. And it would end up being something not unlike Swagger, but machine readable,
Well,
in that we're annotating all our APIs with this.
Yeah, I mean, it is Swagger. If OpenAPI is what you're using today, you carry on using OpenAPI, but it's just like OpenAPI has support for custom metadata, so you just add additional tags in there, right? So you're not migrating away from OpenAPI. You're still using OpenAPI or Avro or Protobuf or whatever. You're just adding additional metadata in there.
Okay, then I think the next place we have to go is how do you use it? There's some kind of query execution layer to this, right?
Exactly. Yeah. So if you think about, so the way that it works is consumers of data write a query, right? And that query is basically a data contract. So they say, right, given this thing I know, so I know, Chris's customer ID, for example, and this is the data contract that I want satisfied. And I define the shape of the data that I care about. And so I publish that up to this query language, this query execution layer, and it's that layer's job to go, okay, well, how do I satisfy that? Like, which systems do I need to talk to, and how do I transform the data that's coming from those systems to build together an object that satisfies that specific data contract? And so in that regard, it looks and feels remarkably like GraphQL, right? GraphQL already has this idea of consumers get to, here is a schema that is potentially composed from lots of different data sources. And consumers of data get to, in the case of GraphQL, consumers of data get to cherry pick the fields that they are interested in. So here is one graph, and you get to pick a subset of fields that you care about. Yeah. We take that another step further, where actually the consumers don't have to become tightly coupled to this one global schema. Consumers just publish a data contract that they care about. So this is the data that I care about. I publish it up to some kind of GraphQL-y kind of thing. It's a taxi query engine. So they publish it to the taxi query engine, and that satisfies that data contract. And that might be calling a couple of REST APIs and querying a database and, doing some gRPC calls, and then stitches the data back together and gives it back to the client.
So it's looking more like GraphQL than, say, something like SQL, where I not only specify what I want, but where I expect that data to be found.
Exactly. The whole point is to decouple the consumers of data from having to know where the producers are, which, to your point about Kafka, is exactly the same goal there, right? Like, producers are dropping messages onto a queue or onto a topic, and the consumers don't really need to know from whence it came. They just know where they can go and get it.
So I have to ask, so how does that resolve if I say something like, here's Chris's social security number, and I want that first name and last name, and there are several competing systems in the bank that will offer up that information given the right social security number. How do you choose which one to resolve it from?
So typically, it depends, right? There's lots of different strategies. Yeah. You can, just like with any kind of query, you can control that. So there are hooks for you to say, right, I want data specifically from this system. That's kind of a trade-off, because you are then saying, right, I only want, the consumers have become aware of the producing systems, but it's not the end of the world, right? So you can say, yeah, I want social security data, but I only want it from the golden source, for example. You can also add constraints into the data contract. So you can say, I want Chris's social security number, but I want it where the age of the data is less than 24 hours old, for example, in case you're rapidly changing your social security number.
It's the only way I'll stay ahead of the system.
I wish we hadn't picked that as an example, because this whole thing feels like a identity fraud podcast.
And now, by saying those words, you flagged us in a database. Yeah. Thanks very much, Marty.
So like out of the gate, the query engine is designed to optimize for, given all other constraints being equal, the query engine will optimize for the fewest number of hops, right? So what is the fastest way of resolving this data product on a field by field basis? And it applies kind of sensible things like caching and if one given route doesn't work, then it will fail over to the next. So if you're happy to just leave it entirely up to the query engine, it will by default go for kind of the shortest possible path. When we built the query engine, we built it so that those heuristics were pluggable, because we thought someone would come along and they would say, well, actually, I want these consumers get access to high quality data. And so, this is a real thing, right? Like especially in banks, you go, right, these consumers get access to this data, which is up to the second, but every read costs us a lot of money. These consumers, they don't need it to be as fresh. And so they get access to this other stuff. So the intention is that those kind of algorithms are tunable. No one's ever done it, so we don't know how well that's going to work when that requirement comes along. But the intent is that those heuristics are tunable, so you can kind of massage the execution engine.
Right.
But without that, you can say, right, I want to restrict it down to these sources, or I want it from any source but not these sources, or I want it where the data satisfies these specific constraints. Okay, so you get like a lot of levers that you can pull.
So another thorny thing in that is like data cardinality, I'm thinking, right? So I'm trying to come up with an example here. Imagine you are querying a system and you want each customer and their address, right? That's fine. This customer, nested address, easy. One day we add in the high net worth investors database, and now they want to return all the different addresses you have, because you're very rich and you live at several places around the world. And in their world, one person maps to many different addresses.
Yep.
How do you resolve something like that?
Probably not as well as we could, I think, is the honest answer at the moment.
I like an honest answer.
And I think, as we've been evolving the platform, we have seen different places where the language has kind of struggled a little bit. And I do think that cardinality, especially kind of the idea of going from a one-to-one, one-to-many, many-to-one kind of thing, like it's fine for it's fine for saying give me a collection of addresses, but where a consumer has previously expected there to be one and now there are many, that would at the moment result in an error. And I definitely think that's a space that we would want to kind of evolve and work out what better looks like for that. I think the challenge there is around where there are many, where previously there was one, which one do you pick? And we don't have a great way of knowing that. There are ways of expressing that to say, I want to filter this down to only pick the primary residence, so you can express that in the query language. But that requires you ahead of time to know that it was a one-to-many relationship. And I think in your example, it was kind of one-to-one and then changed. So I definitely think it's a space that we could probably evolve and do better.
That's in that. I'm gonna pick on this, even though you've admitted that it's perhaps not a strong point. But
what a bully!
I'm sorry, but I'm curious. And my curiosity leads me in these things. If I wrote a query that only touched two of the regular systems, and I got back the single address for each customer, and then I added one field that I didn't realize is now going to tag into the high net worth database, will it suddenly change the address field just because I've added in one column without realizing that it matters?
No, because the query engine is basically doing a graph navigation, right, to work out which data sources to go to. So adding in a field to pull in a data from another source doesn't pull in all of the other data that was available at that source, right? But I think going back to the earlier point where if across the graph, historically there was only one place to get address from, and it was a single value, and now there is another place that you can get addresses from, and it's a collection. When that kind of change gets introduced, then the graph doesn't behave as well as it should. And
Okay. So, what does this language look like? Does it look more like GraphQL than SQL, or is it its own thing?
yeah, it looks like on the query language, it feels a bit like a GraphQL object. Taxi has an expression language that sits inside of it. So I think this is something that GraphQL kind of has, but it's a little bit awkward in terms of everything's kind of a decorator or an annotation, and it's kind of there. Whereas in Taxi, we have a very rich expression language that lets you do kind of arbitrary things. For example, you can say, right, I want give me the customer's name, but I want the customer name transformed to uppercase. So you can embed like kind of transformation logic inside your data contract, and then you get the benefit of that transformation logic running on the query engine rather than on your consuming client. And that logic can become really quite complex as well. So you can say, right, I want to know, you can define a concept that says, right, the profit for a given instrument or for a given thing is the wholesale price plus the cost of goods minus the apportioned warehouse cost. I don't know. That's kind of the concept of profit. So you can define that as a semantic concept, and then you can say, right, I want to know on this product, I want to know what the profit is, and you get the value back. But the semantic layer has described all of the different logic behind that, and so you get kind of consistent evaluation.
Right. Yeah.
So it's at the outset it looks and feels a lot like GraphQL, but the underlying language is quite a bit richer. Yeah.
If I defined profit, just to check, I understand this. If I defined profit the way you've described, and I queried one system and got the profit back, and then queried another system which had all the same fields with different names, would that automatically resolve correctly?
Well, the resolution logic would be applied consistently across the graph, which is slightly different from what you're asking.
Okay.
But across the graph, because if you ask the system, you're not saying I want to know the profit as defined in this Postgres database. You're saying across the graph, here is the definition, like the semantic definition of profit, and for a given product, it's calculated. Profit is calculated using this formula. So when I ask for information about a product, if I say I want to know the profit, what that might do by adding that one field into my query, it might mean all of a sudden now we need to talk to 7 other systems because we need to go and get the cost of the warehouse rental and like whatever the different things are that are coming into it. So that evaluation will get applied consistently every time you ask the question.
Okay. Yeah.
Because the semantic concepts are not about reading a specific field from a specific table, for example. It's about saying semantically, this is how this concept exists. And then when you furnish that idea, it's up to the graph to say, well, this is the places that you can go and fetch that data.
Okay, yeah. So that would suggest to me that if I think of horrible problems I've faced in the past.
This is so fun.
This is like a game show that would be watched by very few people. We ask the guests difficult questions against the clock. Okay, so you can imagine in a company like that saying, oh, we're all moving to SAP or whatever, and we're building in a new system that contains all that data in one place. The day we switch that on and switch the old systems off, am I going to expect my taxi queries to just magically carry across?
Yeah. That's the way it's supposed to work. Yeah, assuming that the data is available, it doesn't have to come from the same place. But assuming that the data is available, then it will switch across. And that kind of so all of these questions are super fun, right? And they come up all the time when we start working with new teams, right? And it's things like, what if we tag that value wrong? Like, what if a team tags a number tags a field as the date moved in, and it's actually the date that they became responsible for the account, right? And they get that wrong.
Yeah.
And that's a really common question that comes up when we start working with new teams. And it's what if you do get that wrong? That's a bad thing, right? Like, we can agree that there's real problems if you use this data incorrectly. And like if we compare that to the way that we build integration today, the people who make those decisions today are not the people who know the system, but they're the people who are consuming the data from the system, right? Because every time you build an integration, you start from zero. You go, right, I've got to go and pull in the data from the account system. And there's these two different date fields. Which one am I going to read? And the guy that's building the integration goes, well, I'm going to read that one. And what if they get it wrong, right? And when we build integration today, we make that decision over and over and over and over. Every team that builds that integration kind of goes, yeah, well, I've got to pick the field and I'm going to pick that one, and you just hope that they get the right one. And what this does is it inverts it, and it says, well, the producer becomes responsible for saying, hey, this is my semantic contract. So this field relates to this business concept. So long as you know the business concept that you're asking for, it doesn't really matter what the field name is. And, we see it in legacy systems. A lot of the time they're like, completely nonsensical names, right?
And so depending on how far you go back, you're back to the mainframes, and it's like 3 character codes, right?
Yeah, exactly. And so, in the example of kind of switching off one system and switching on another, assuming that you got all your semantic modeling done correctly, then it will just kind of switch across. But that feels like such an important decision that it should be left to the teams that author the systems and know the systems to make. And those should be decisions that we make once, categorizing our data. In fact, defining contracts for our data and our API specs is a thing that should be done once by the teams that publish the API specs, right? They're the ones who know the data. It's the same reason that, OpenAPI exists, so that teams that are authoring these API specs can say, this is the contract of my API. And we don't leave it to the consuming teams to kind of eyeball the JSON and go, I guess I can work out what the contract is. I can reverse engineer it, right? Yeah. So that same responsibility, it sits with those teams. It sits with the teams that know the data the best. They're the best placed to describe and describe the data.
That makes sense. And I've already asked you this question, but I'm going to ask it again and labour the point because I want to be doubly sure. If I'm in the situation where I'm building out this system and I find that the producing team is busy, overloaded, reluctant, can't get their act together, and I, as the consumer, write this taxi definition, I can then down the line say to them when they're less busy, would you like to adopt my taxi definition?
Exactly.
And evolve from there. Yep. Okay, so I'm not blocked on them defining the semantics. I can just benefit from it.
Yeah, exactly.
Right. Okay. Then I think we have to get into how you actually execute one of these definitions. It's not always obvious to separate out the query from the query execution, but here it seems like a very natural partitioning. When I give you a query that says, give me these 4 fields, how do you actually execute it?
Okay, so it's super fun. So before that happens, we've kind of consumed all of these different API specs with their semantics. So a taxi server it's got the kind of system agnostic taxonomy. So that's just your collection of nouns that's defined in taxi. So first name is a string and last name is a string. So it's read that probably from a Git repository somewhere. And then it's got a bunch of different kind of systems that have published their API specs with these semantics inside of them, right? So,
and is that just a list of endpoints where it can find the latest definition?
It depends, right? It's a combination of endpoints that we're reading from. It's Avro files chucked in a schema repository somewhere. It's Git repositories that we're reading. It's all of those different things.
Okay.
One of the goals of Taxi when we set out with this was that we really wanted to meet developers where they are, right? Whatever your tool set and whatever your way of working is, you should be able to carry on doing that, right? You shouldn't have to rebuild your stack or adopt a new way of working.
Yeah, that's both nice and the reality of you can't get banks to change just for you, right?
Well, yeah, and also, this isn't just banks, but large organizations have different ways of doing stuff. Different teams follow different Git branching strategies. They follow different they've got different technologies, so they follow different conventions. The C# team will not follow the same conventions as the Go team or as the Java team, right? They just won't. Yeah. And the tools are different. So you got to meet them there. and I guess this is one of my challenges, like the way that GraphQL has approached this is like the producing teams kind of have to adopt one standard for this to work, and that feels like quite a bit of friction, right? If you're an Avro team, you should carry on being an Avro team. If you're a protobuf team, like we don't care, but carry on being a protobuf team, right? Our job is to work within that stack. So you have these specs, and so like the query engines kind of gobble them all up. And internally, we've built this massive graph. So the API specs tell us kind of where a system is, like what's its IP address, what port is it on. It tells us what protocol to speak, like is it JSON or is it protobuf or is it Avro? So we know kind of where you are and how to talk to you through your API specs.
Yeah.
And then the semantics tell us what that means, right? So it tells us then that, and like an example that I use all the time is, given a customer ID, I want to know their account balance. And that is maybe split across 3 different systems. There's a team that goes from, say, that has customer information where I can look up a customer from a customer ID. And then there's a cards team that has kind of the card information. And there's another transaction system that has balances. And so we've got these 3 different specs that talk about this data and how it kind of connects. And so we gobble all that stuff up, and then we build this big massive graph that then we can do, relatively unexciting like graph traversal, right? To say, given the set of things that I know, like, Chris's customer number, this is the data that I want to find out. I want to know these 20 different attributes, and we can just do kind of graph traversal from the thing that I know to the thing that I'm trying to get to. And if we traverse that semantically along the way, we can also find out that in order to get from, Chris's customer number to his account balance, we have to first call a system to get his card number, and then call another system to get his account balance, and that might be a database lookup along the way, or a SOAP request that we do along the way.
You're not allowed to swear on the podcast.
And so it becomes like the process of how do I execute this query is just graph traversal, right? It's like
those algorithms we were supposed to have learned at university.
Yeah, it's plain old shortest path. Do
you do things like you must end up with situations where you gather all this data together and you find that you can get this field from 3 different systems, and you try and sort and optimize the result to say 2 systems would be enough, so let's just go to 2.
Yeah. So we are doing the shortest possible path. So across the query, we are looking to optimize. Again, assuming that both pieces of information are semantically equivalent, which is really important. Assuming that they are both semantically equivalent, and there's no constraints that say you must read from this system or it must satisfy these other kind of attributes. If there are genuinely 2 candidates to go and pick from, it will optimize for the smallest number of network hops.
Right, network hops specifically.
Well, yeah. Well, I mean, yeah, we apply. I mean, like in any good graph, we apply a cost across each of the different transitions from across the graph, and we apply a higher cost to a network hop than we do to, say, reading a field from a JSON blob that we've already got in memory.
Okay, so that implies costing models and caching. Tell me about costing models. Is it just number of network hops, or do you do things like you mentioned this is an expensive system to talk to, or this is an overloaded system, try not to go to that one, go to one of the read-only copies?
Yeah, so we want to do that, and like I say, we kind of built with the expectation of doing that kind of stuff because it's a cool problem. We just want a use case to come along. So if you're out there and have a use case like that, we want to solve for that. The intent too is to be able to do that dynamically, to be able to say, over time, there are 2 different systems that I can go to, and I notice that performance on system A is slower than performance on system B, and so I will, gradually send more traffic to system B because I'm getting better performance results from that, and so kind of dynamically adjusting the performance of the graph as you're going. So it's designed to handle that kind of stuff. We haven't built those implementations because we kind of want a real person to work with to do it. A real use case. But they are really fun problems. Like that's kind of the heart of it, and getting to a point where, and again, where consumers can say, I want this data, and I am happy for my request to take an extra 30 seconds because it doesn't really matter, versus I want this data and I need my answer as fast as possible. So consumers a lot of the time have a say in that, right? That's part of the data contract that they're submitting. And the teams that kind of build and think about data contracts today, data contracts is a really exciting space. There's a lot of stuff going on in there. And they are thinking about like these data quality attributes around data, like timeliness and the response times is another one of those, right? I'm going to ask this thing and I want this data back as fast as possible, or I want it, and so you can cache this aggressively, or I want it as up to date as possible, and I'm happy for that call to take longer. So those are the kind of quality attributes that in theory a consumer should be able to say, and then likewise a producer might want to be able to say, well, there are rate limits for calling me, or you get rate limited at a different rate. Team A gets rate limited at a different rate than Team B. And so a query engine should be able to consider those kind of heuristics and tune its graph accordingly.
Yeah, okay. Where is the query engine running? Is it like one centralized query engine, or am I running a query engine locally in my process that's doing the consumption?
You can do it in lots of different ways, right?
Yeah.
The query engine itself it's written on the JVM. If you want to, you can actually embed that in your microservice or in your consumer if you're built on the JVM. So you can entirely distribute this stuff, right? You still have the problem of I need like a central registry to go and fetch all of those schemas from. But that's a solvable problem. But you can kind of embed it, or you can run this on a Lambda. So you can have a Lambda that scales out infinitely to handle the request execution. Or we have a product that we build, which is Orbital, which is our kind of our commercial version of the TaxiQL query engine. And that's a thing that you can scale out as well. So you can send it to that. So there's lots of different query execution models. You should definitely use Orbital because that's the one that pays the bills and keeps the lights on.
At least you're honest.
But if you want to, you can embed a taxi query engine directly inside your Spring Boot app, for example.
Right, and that is open source.
Yeah. Yep. Apache 2. Yep.
Okay. JVM written in. I think I've heard you say this before. It's written in Kotlin, right?
It is. Yeah.
Kotlin?
We're Kotlin OGs. We've been building on Kotlin since before it was cool, man. Why Kotlin? Well, I'm a JVM guy. I have been for a really long time. Kotlin it's just beautiful ergonomics for working. It's a super productive language. It gets out of your way. It's really functional. It's just a fun language to program in. I wish there was a better answer than that, but the JVM is really fast. It gets a lot of hate, but man, it's fast. And there's some really cool stuff around native images. That means that memory consumption is and startup time is not what it used to be. So it's a really cool ecosystem to be in.
Okay, just love of language on that platform.
Yeah,
fair enough. Yeah, that's good enough reason.
It really is a great language. Kotlin, a lot of people think of it as an Android language, but it was a server-side JVM language, first and foremost. And you see the Spring team embracing Kotlin really heavily. It is just a great language. I heart Kotlin.
What do you like about it?
Sponsor.
Give me your favorite thing about it.
It's like I say, it's very succinct. So you get all the performance of the JVM, right? So it's fast, but it's very ergonomic. It's very succinct. So you can, and I will say that Java has caught up a lot, right? So I think we were on maybe Java 11 or Java 17 when we started working on this stuff, which is a lot of releases ago.
Yeah.
But Kotlin has this idea of data classes. None of these are brand new ideas, but they just kind of came along at a timely way. So data classes, which is a way of just saying, hey, this is immutable, and you have the equals and hash code, all the kind of boilerplate stuff. The system will worry about that for you. Like the compiler will deal with that for you. So it's very succinct in that way. It's got strong ideas around immutability, strong ideas about nullability. It's got extension functions that allow you to write things that are very that become very kind of fluent, and you can take a class and then you can add an extension function later on, which lets you do nice things with collections, and it's just a great language.
I feel that, and I think you have to give Kotlin and Scala credit for getting Java to get out of its doldrums and start innovating again, right?
Yeah, absolutely. I think there was this big dearth of innovation where kind of Java didn't move on from 8, and then I actually also think I don't know. I've got no evidence to support this, but I think that the JavaScript and TypeScript community deserves some praise here as well, because I think JavaScript and TypeScript as a kind of another general purpose kind of easy access programming language was adding things and really kind of helping, I think, drive functional programming into the mainstream at the time that Java was still very anonymous classes and lots and lots and lots of boilerplate. And so I think you saw JavaScript and TypeScript were really kind of driving functional programming as a mainstream concept, and then Kotlin came along and so did Scala, and they kind of were embracing these concepts on the JVM, and with varying degrees of ceremony. And I think what Kotlin did really nicely was they made functional concepts really, really easy to do well. It looks and feels a lot like writing JavaScript, except you have, types and a compiler that will help you if you make a mistake. And so I think JavaScript sort of re-energized, and we saw Node starting to get traction as a server-side language.
They must have felt the threat from that.
They must have gone, well, because for ages you would just laugh and say, well, there's no way that JavaScript can really be fast, and then all of a sudden it was. And you'd go, well, there's no way you'd build a serious application in JavaScript on the back end. And then all of a sudden people did. And they did it really well. And it was good. And and so I don't know. I have no proof that it has anything to do with the kind of revitalization of Java, but I do think that people kind of looked at what was going on, and there's some great ideas out there that are kind of in the mainstream, and we should adopt them and move them in.
Yeah. There was definitely a sense that Java thought it was finished, and then various things conspired to make it realize actually there's more innovation left to find.
Yeah.
Anyway, right, that's your brief respite from being grilled over queries. We're going back to... Because one thing, let me give you some more hard things to deal with in the query engine world, right? You can easily imagine... We've touched on this with Avro, right? Mm-hmm. Imagine you've got a system where there are Actually, no, but I'm going to skip back. There's another question I've got to ask you first. How do you deal with streaming data? Because I know you've got Kafka integration.
Yeah, we do a lot with Kafka, yeah.
And it's a very different thing to go to a semi-static database and query stuff versus a log which has the past billion records all just streaming out in real time. So how do you handle those differences?
We don't at the moment support the idea of I want to read a specific index from Kafka. And I don't, a lot of people aren't, there are people who use kind of Kafka purely as a log and apply compaction, and but also a lot of people are just using it as a pure event stream, right? So if you want to use it as a pure event stream, that's fine, right? We can consume an event stream, and you can say, right, I want to stream this data. But again, consumers of the data get to say, I want to stream the data, but this is the data contract that I want to consume. And I think in the world of streaming data and kind of event-based architectures, I think that often teams that are building these systems kind of have a choice to make around the way that they design their events, right? So producers have to go, well, am I going to have anemic events that describe the bare minimum pieces of information required that describe this event? So a user clicked a link, so we might want to know the user ID and the, I don't know, like 4 or 5 fields that kind of describe that event.
Yeah, who clicked what, when, and that's the whole event.
That's the whole thing. Yeah. And then consumers of that data, they need richer information. Like they don't just want to know the customer ID, but they want to know first name, last name, like what their customer status is, that kind of stuff, right? So consumers, in order to consume that data, they have this burden of enrichment. And different consumers will need to enrich in different ways. So they will consume the data, and then in order to make use of it, they need to query a bunch of other systems or do a bunch of other REST API calls or join a bunch of other streams together in order to get the data that's meaningful to them. And so if you have these anemic events, the burden kind of shifts to consumers to do the enrichment. Or if you have these, where you can flip that on its head and you have these really fat events where producers go, okay, well, in order for this event data to be useful, I'm not just going to tell you like the bare minimum 3 things. I'm going to like pump it full with lots of information, which I think you guys might want to know. And so then the producer has to wear the burden of enrichment, and so they become coupled to all the other enrichment services that they need to talk to, right? But when they emit the data, so it's a trade-off. And I think what's really nice about the way that Taxi lets you approach this is it's neither of those things, right? The consumer defines the data contract that they want. The producer defines the data contract that they're going to satisfy. And where those two things don't line up, the query engine sitting in the middle has the job of enrichment. So the consumer doesn't have to know that in order to enrich this event, they have to talk to 3 other microservices and query an application database. They just publish a data contract that says, I want a stream of, customer sign up events, and I want these 20 fields on my stream. And they publish that as a data contract. And then the query engine goes, okay, well, in order to get that, first of all, I need to find which system is streaming these events, and it's a RabbitMQ or it's Kafka or it's SQS or something. So I'm going to subscribe to that stream, and then as each event comes, I'm going to enrich that to satisfy the consumer contract. And so the producer and the consumer remain both decoupled from each other, but also decoupled from all the enrichment services. So when those services change, they don't have to go and fix their integration. But the consumer's getting the data they want, and the producer is publishing the data in the way that makes sense to them.
Okay, that raises the question of how you deal with time and versioning. Because, like, if I query a Kafka stream and Taxi is enriching it with address data today, a month later they've changed their address, I go and requery the same data. Do I get the old events with the new address, or do I get the old events with the old address?
I mean, that's a great question. We don't solve that problem out of the box, but again, if you think about the way that the consumer would have to solve that problem, they also would need to. So, like, there's no magic to magically solve that problem. But if a consumer wanted to be able to say, "Hey, I want," in a bitemporal system, I want, a customer signed up event, and I want their address at the time of that event being broadcast. If they publish those requirements in the data contract, then when the data contract is finished, we will query the system to satisfy those constraints. But if you don't specify those constraints, then you just get whichever system is publishing address data. And so what it does is it forces consumers of data to be really explicit about what their requirements actually are. Right? Do you want?
Okay.
And again, that's the right place. Consumers should be saying, this is the contract of data that I need satisfied.
So you're you're specifying the event data as a join condition on the address.
I look at it a different way without having to. Like, I don't want to have to think about how this query gets executed. Right? I don't want to get it like. For me as a consumer, I don't want to have to specify join conditions. What I do want to specify is constraints on data. So I want a customer signed up event and I want their address, but I don't just want any address. I want the address that was true at a specific point in time. Okay. So if I can express that as a constraint against the address object, and Taxi has this expression language for defining constraints, then the query engine will go, okay, well, I need to fetch address data, but I can't just fetch it from any system. I have to fetch it from a system that is published that they can satisfy these constraints. So they can give me address data, but also they can give me address data at a specific point in time. And so then the query engine can go, great, of all of these different places that I can go and get address data from, for this data contract, given this set of requirements, I will go and talk to that system.
What kind of error do you get when that constraint isn't satisfiable?
You get an error that says there was no data. I think it says there was no data available or no sources available to satisfy this data with the constraints provided.
Okay. So then I would have to relax the constraint or get a new producer to supply.
Yeah. Which again, it's not really a query engine problem, right? There just is no data available to go and satisfy data for the constraints that you've specified.
Yeah, okay, that's fair. What do you have things like, and this I suppose relates to the optimization and costing thing, but do you have things like the query plan comes back and says go to this system, you go to that system and it's throwing a 500 error, and you can't get it, but there's another system you could have gone to.
Yep.
You just chose not to use that one. What happens there?
We fail over and we try the next one.
Transparently.
We also give you back full lineage. So one of the nice side effects of having a query engine do all of this is, in addition to the data, we will give you end-to-end lineage that says not just which systems did I speak to, but for every given field in the response that was served, show me all of the computations and all of the different systems that we spoke to, including the systems that we tried and failed for that specific field. So you get kind of real soup to nuts kind of lineage on a attribute level, because in a data contract, each attribute might have come from a different system, or it might be the result of the composition of 7 different systems working together, like in the example of profit and loss that we talked about before, right? So you can trace all of those different attributes back, all of those different calls back on a per attribute level. So yeah, we will, if there is more than one way of satisfying it and the initial path fails, then we will fail over and try the next path. If there are retry constraints on the system, we'll try and honor those retry constraints, and if that fails, then we'll go, okay, what else can we do? Where else can we look to satisfy this data contract?
Okay, that's interesting. The lineage stuff, I'm guessing that's the kind of thing that gets really popular with large enterprises.
Yeah. I mean, lineage is this really weird thing, right? Like, I think I've got to be careful here because, I think it's the kind of thing that large enterprises like to buy as kind of an insurance policy, right? So they have a often regulated obligation in order to regulated obligation to capture and store lineage, and oftentimes what happens is lineage gets written down into a system, and they say, right, here, when we at design time, we're going to build this integration, and we're going to write down all the different systems that it speaks to, and we're going to stick it in our lineage system, and then we're going to lock it down, and we're going to make it really hard to evolve and to change, because if that lineage is wrong, we're in trouble with the regulators.
Yeah.
But over time, things happen and they drift, right? And so I think like design time lineage is often, it's like that old adage, right? Like the one thing worse than no documentation is out of date documentation, right? And the same is kind of true of lineage. If it's a design time artifact, not a runtime artifact, how do you know that it's still correct? Like and the thing that's ironic about that is the companies that spend huge amounts of money on lineage systems, which are kind of captured at design time, are the companies that have these massive fines if they get it wrong, but don't really have a great answer for the question of, well, how do you know that that's the same as the logic that's written inside the script, like the Java application that is generating this data? Like, how do you know that it's correct? and a lot of times they don't, because like design time lineage, it's kind of there's a certain degree of hope mixed in that, I just hope that things haven't drifted.
Yeah, I hope things match the spec document we wrote 18 months ago.
Exactly.
Yeah, good luck with that.
Yeah, exactly. And how do you know that it hasn't drifted?
Yeah, almost certainly you know that it must have done.
Yeah,
because that's life, right?
Yeah.
Yeah.
Okay. And in large complex organizations, even often they'll go as far as column lineage, right? So the values in this column are theoretically computed like this. But if you have two rows in a table and one represents an FX trade and another represents an interest rate swap, the way that those two fields were calculated will often be different depending on the type of product that you're trading, right? In finance anyway. And so column level lineage often isn't enough. You really need to be able to say this specific value was calculated in this specific way, and here's all of the inputs that we used in order to calculate that value. Not just in theory to calculate this value we spoke to these systems, but no, for this value of 7, we got there by getting 4 from this system and 3 from that system. And we got 3 by feeding in this ID. We got that ID by talking to another system. So we're really tracing it all the way back. That's really what, if you care about lineage, that's really the stuff that matters.
Yeah, it's the only way to do it accurately, and it's not something you can bolt on later very easily. Yeah. Okay, I can see how this all begins to hang together. Let's talk about sticking it into the real, horrible, thorny world. Like, if this seemed like a good thing, and I was using it at a different bank that you'd never heard of, or I'm saying bank too much, it's just my go-to shorthand for large organization that doesn't talk to itself. Right?
Yeah.
But inevitably, I'm going to come up with a new system that not only hasn't annotated their API, but has a kind of API you haven't written a connection for yet. How much work is it to say, here's this weird mainframe, and I want to use that as a new query source?
We've gotten it down to a fine art, so we can kind of crank out, a new connector within a day or two. But it's all open source, and all of the code is up there. So if you wanted to go and build a mainframe connector that speaks some esoteric mainframe protocol, you could go and implement one yourself.
What does it look like? Is there an interface that I write, and how large is that interface? Or
so you implement we call them invokers. So you implement an invoker that understands how to speak to Kafka, or understands how to speak to MongoDB, or understands how to speak to weird mainframe. And so you implement. So there's always two parts to it, right? One is, and you touched on both of them. One is, how do I describe the semantics of the contract, and that is different from how do I interact with that system, and how do I send messages backwards and forwards over the wire. So one is around structural, like what's the DNS name, what's the how do I send data across on the wire, and one is semantic, what's the meaning of the data that I get back, and how do I interpret that. And so those are implemented as separate concerns. And a lot of the time, OpenAPI is a great example where those two things kind of travel as one, right? But sometimes they will be separate. So you could implement a invoker that knows how to speak to a mainframe, and then you can have a schema translator that understands, our weird binary protocol language. And so you need to build those two different things. Both of them are pretty quick to build, and then all of a sudden, the taxi engine knows now how to talk to your system, and it will call that invoker at the right time, and it will go off and get data, and it will give data back.
And you can just magically join it into other stuff.
Yeah. Once the query engine kind of understands how to speak to that system, and there's a schema that describes what data that system can give back, we'll call it at the right time.
How many kinds of system can you connect to these days?
It's pretty modest at the moment. I think we've probably got, 20 or so different combinations that are in there. But given that we're not trying to solve the problem, you can't come to Orbital or Taxi and get a schema for HubSpot, right? We're not trying to solve the problem of how do I speak to that application, because again, I think other people have done a great job of solving that. So we really only have to solve how do I speak to Mongo, how do I speak to Kafka, how do I speak to RabbitMQ, right? So you get a lot more surface area with a lot fewer number of connectors. And again, like we have support for SOAP, gRPC, Avro, JSON, CSV, XML. That's most of the enterprise systems kind of covered there, right?
And you've covered a vast swathe with just that bunch.
Yeah, and we can support speaking to Kafka, Rabbit. We can invoke Lambda functions. We can read from blob stores. We can stream data from an S3 bucket. Again, like you pretty quickly get coverage of a lot of the surface area you need to cover to build something that's useful, because we don't have to worry about building. Like our goal isn't to build for HubSpot or to build for Google Sheets or those kind of things. It's to build at the system level, for system level integration. We're used by developers. We're not used by like marketing teams that want to do kind of citizen integration. We're used by developers who are comfortable and just want to spend less time on the boilerplate stuff.
Yeah, okay, that makes sense. So what's left to do? Like where do you need to take it next? What's missing?
I mean, I guess lots of stuff. There's always different optimizations that we want to be able to add into the query engine. I think TaxiQL is a fun thing to build, but we are always having customers come to us and say, "Hey, how do I express this query? How do I query this kind of stuff?" And so we can kind of continually evolving the language as new requirements come in. That also, in turn, makes us look back at some of the decisions that we made a couple of years ago. I'm sure that was a good idea at the time, but
Can you give me an example?
I think. I mean, we kind of touched on one with cardinality before, and how you express going from an object of one to an object of many. And I feel like we got that kind of very wrong in the early days. And we've kind of improved the syntax a little bit now to kind of talk about how you navigate an object and then how you iterate an object. And given that this is supposed to be like Taxi is supposed to be very declarative, so you can't really, like, you don't define a for each loop, right? Instead, you're just saying, hey, I want a collection of address objects, but I want that by selecting. I don't want just any selection of address objects. I want it from this aspect of source data. And that was a thing that we didn't really have great semantics for in the early days. And we have kind of bolted it on, and I think we screwed it up a bit the first time. And I feel like just the last few months we've landed on something that is a little bit more expressive and feels a bit more natural in the way that you kind of write it.
Okay.
So there's we're doing a bunch of work around SDKs as well. So one of the really interesting things is we spent a bunch of time working on Taxi and working on the query engine and on the tooling ecosystem, the compiler, and all the kind of stuff, and make it very hackable and very pluggable. And we didn't put a huge amount of time or effort into building SDKs. I mean, we built some, but they were kind of rubbish. And so we've been doing a bunch of work around, and I think this is a thing that GraphQL does phenomenally well. Like the GraphQL tooling for JavaScript developers is just gold standard. It's beautiful, and they've absolutely nailed it. And so we've kind of looked at that and gone, if I'm building a backend application and I happen to be coding in JavaScript or in TypeScript, I would want to be able to write a taxi query that says, stream data from an S3 bucket and enrich it against a Mongo thing, and call a bunch of other REST APIs, and then write it into my Postgres database, right? And that's a thing that, as a TypeScript engineer, I want to be able to do, but I don't want to have to pull in all of those other drivers. And so Taxi is a really nice way of solving that problem. It's just our SDK tools were kind of gross for that, and so we've we've spent a bunch of time kind of looking at what good looks like, and I do think that in that space, what GraphQL does is beautiful, and so we've kind of borrowed heavily from that ecosystem and been inspired by it to go, like they have this great tooling that you can define a query inside your JavaScript, and there's this phenomenal tooling that's kind of parsing your JavaScript in real time and going, right, well, here's the shape of that object, so I'm going to run a compiler in the background to generate some classes for you, so you get like nice, strongly typed stuff as you're going, as you're typing. And the GraphQL ecosystem does that really well, and so we've gone, we should be able to do that as well as that. So, we've got some stuff coming out in that space, and the same in kind of, again, we want to have great support across the languages that developers are building in. So that's, for us, it's obviously Kotlin and JVM languages, C# and .NET languages. So like right now our focus is on TypeScript, JavaScript, and the JVM, but we're excited we want to meet developers where they are. So we want to do tooling for .NET developers and tooling for Go developers and tooling for line of business languages.
Yeah, I imagine that's one of those things where, sure, there's an overhead for each language, but it's the design up front, figuring out what tools you want to supply. That's the really tricky part.
And also the idioms, right? Like the way that TypeScript developers work and their expectations of their iteration cycle are different from the way that a Java developer works. And like you can't take something that works really well for a JavaScript developer and just dump it into the transpile it into Java and dump it into the Java ecosystem, because those developers work differently, right? A JavaScript developer will quite happily have a node process that's transpiling code in the background as they're typing, whereas a Java developer is going to be running like a Maven build and do their transpiling and their code gen like as part of an active thing that I run. And so the way that those developers work, the idioms and the practices, like you have to do something that works well within that tool set, within that ecosystem. And so we're kind of picking the ones that we know because we feel like we can solve for that. We're not Go developers, so we don't know what the Go idioms are and what good looks like in that ecosystem. So that's something.
So eventually you're going to have to hire like native speakers. You're going to have to hire Go developers.
Or they'll come and find us on GitHub and maybe tell us what good would look like, and we can,
Knowing the internet, they'll tell you what bad looks like, and then they might tell you what good looks like.
We won't tell you what good looks like, but we'll tell you why all of the decisions that you've made were wrong.
Okay, well, that's a starting point. We'll move on from there.
Yeah.
I'm going to circle back because there's one thing you mentioned that we didn't actually cover. You briefly hinted at it, which is writing. We've talked about querying this whole way, but you mentioned writing the data into Postgres. So it's not just that I'm querying, like I'm taking these queries programmatically. I can also define a sink to dump the data into.
Yeah, absolutely. And the syntax is a little bit different. So I think philosophically, the query engine will read from wherever it can to satisfy the data contract given the constraints that it's got, right? So it'll look at all the different sources. But when you're writing, you do want to be a little bit more explicit, right? You do want to say, I want to write this to that specific database, or I want to call that specific API. So the syntax is a little bit more deliberate in that space. But yeah, I mean, people who are using us to, like, common use cases are, I want to read data from an S3 bucket, enrich it, transform it, and write it onto Kafka, for example, or write it into a database, or cache it and then serve it over HTTP, like those kinds of things. So reads and writes are part of the language. I think there's some really interesting stuff that's kind of in the background of cool experiments to write around going beyond explicitly saying I want to call this service and going to I want to perform this action. And I think there's some really nice abstractions that you can apply in that space around kind of intent or action to say, I want to read some data and then I want to charge the customer. And I don't necessarily know which API I want to call to charge the customer. I just want to satisfy an intent. And I think that's interesting. That's nothing more than an idea at the moment. But I feel like, our goal is to be declarative around the way that you write this integration rather than imperative. And so moving more towards I want to satisfy this intent feels
Yeah.
kind of more natural in our space.
You've been semantically tagging nouns. You're ready to try some verbs.
Yeah.
We'll get you back on the show when you get to adjectives. However that will look. Oh, I know.
Yeah.
That's the cost optimizer when you can do it quickly.
Yeah. I want this data cheap.
Yeah. Awesome. I'll look forward to that. In the meantime, best of luck with the next version.
Thank you very much. Yeah.
Marty, thanks for joining me.
Thank you so much for having me, Chris. It's been fantastic.
Real fun. Cheers.
Thanks.
Thank you, Marty. If you want to give Taxi a closer look, you'll find links in the show notes, as always. Personally, I would start with the link to the playground because it's a nice visual way to see what it looks like and get a feel for how it's going to work in practice. And then there are links to the docs and the GitHub repo and all that from there. Since we recorded that episode, I have to say there's one more question that I wish I'd asked Marty, which is about agentic AI, MCP support and all that. Because I'm fairly sure that AI is going to change the integration space, especially in that we left it to the last minute angle of integration. Because AI is actually really good at duct taping things together in a hurry. It's integration that's good enough in a pinch. But then it gets much, much better the more relevant context you can feed it up front. So having a machine-readable description of how to meaningfully relate different systems will give you better results. I think there might be a really nice synergy between something like Taxi and AI. I wish we'd explored that. Maybe we'll get Marty back for a bonus episode someday. If you'd like to hear that, then let me know by leaving a comment or liking this episode or sharing it with someone who's currently stuck in a systems integration meeting, slowly gnawing their arm off. And tell them to use their remaining arm to click subscribe, because we'll be back soon with another look at the software world. Until then, I've been your host, Chris Jenkins. This has been Developer Voices with Marty Pitt. Thanks for listening.